yesterday we did, and I'll switch back to what we did. We did product and sum, which was if we're in this form, x squared plus bx plus c, we said our product was c and our sum was b, meaning two numbers got to multiply to give me this number, but add together to give me this number. And then we would say, okay, for our product, what are we divisible by? For 12, we were like, okay, 1 and 12 make 12, 3 and 4 make 12, 6 and 2 make 12. What? Of course Adam's there. What the hell is that?
The truck, they're loading the truck.
Super necessary. Oh, super necessary right now. It's not too loud. Let's not. Take your jacket off. You have a vest and a hoodie. That's probably why you're hot. Okay, so that was what we did yesterday, just testing those. And then whatever our two integers are, we put those numbers into brackets. Okay? Today, right, and this was just the practice, we're saying, what if there is a number, for example, in front of your x squared term? What if there's a coefficient? That's what it's called, a coefficient in front. So we're going to learn how to factor some of these, right? But first, as kind of like to prep you, we good? To prep you, here's like a thinking question. It's saying a rectangle, which I will draw us a nice little rectangle. A little off, but okay. This rectangle, it says it has an area, meaning the inside is x squared plus 10x plus 16. But we don't know what the length is, and we don't know what the width is. It does not tell us that. So we need to find the length and the width that would give us an area represented by this expression. And then it says also find the dimensions if x equals 4. Right? So step 1, I need to know area is what? What's the area of a rectangle? How do we find it? Length times width. So I need to factor this area expression, x squared plus 10x plus 16. I need to factor it so that I have my two brackets, right? Where one's going to be length and one's going to be width. So, okay, what's my product? Oh, hello, sir. Perfect. What's my product going to be? My C term. 16. Thank you, Georgia. So two numbers that multiply together to give me 16, but add together to give me what? 10. Thank you, Harlow. So, okay, I got to start thinking. What are some numbers? 16 is divisible by. What makes 16? I'm thinking, okay, 1 and 16. You're saying 2 and 8. And I think that's about it. 4 and 4. Right? 1 and 16, can that somehow add or subtract together to give me 10? No. 2 and 8? 2 plus 8's okay. 2 times 8? That's 16. 2 plus 8? That's 10. So, okay, that works. That's our one that works. Right, so it's all just trial and error. So then, with these numbers, I just pop them into brackets. So one bracket's going to be x plus 2 and x plus 8. Voila. That's it. Right? The bigger one, that's going to be your length, right? Because length we know is to be like the larger one of the side lengths. So this is our length. And this one's our width, the smaller one. Right, so I can say those two brackets represent our dimensions. And if I were to refoil this, x times x is x squared, x times 8, 8x, 2 times x, 2x, and then 2 times 8, 16. That gives me this expression here. So you can always check by refoiling. Right, so that's step 1. Step 2 just said, what happens if x is 4? Then what are the dimensions specifically? Right, so, okay. How do you know 6? So where are you plugging this into? Okay, so width, the first one we said is x plus 2. So Chloe's saying that's going to be 4 plus 2, which is 6. And I'm going to just do the same thing with the length bracket. I said that my length is equal to x plus 8. So I'm going to do 4 plus 8. So then I know my width of this rectangle is 6, and my length is 12. Well, so all you have to do is just plug in 4 for x into your expressions that you made. we feel about this? Kind of requires a little bit of geometry knowledge, but otherwise just factoring. Is this okay?
Missy, now you change the x to like 12 and 6.
I changed the x to 4 because we said if x equals 4, then my width is x plus 2 or 4 plus 2, which is 6, right? Same thing. My length is x plus 8, as we said here, and if x is 4, then this is just 4 plus 8, which is 12. So my dimensions of this rectangle are 6 by 12. That's all. Because it says, what are the dimensions of this rectangle if x equals 4? Right? So we have two expressions. This one's for length, this one's for width. They both have an x in it. Exactly. So we're just subbing in x equals 4. How do we feel about this? Is this okay? Am I okay to keep going? Okay, cool. So now when we get into numbers that have a coefficient in front, we're going to see two cases of this. But today is the nice, easy one where you might notice that you can factor out a GCF first before doing in product and sum. That's going to make your life way easier, right? So if I've got this one, I've got 3x squared plus 15x plus 18. What are they all divisible by? They're all divisible by 3. Usually the leading coefficient, that's what this is called, the one that's attached to the x squared, that's your like hint, like your nudge, divide by this, right? So GCF is 3. So I'm going to factor out a 3 out of all of this. And I saw some people didn't do this on the test, but if you're factoring something, you have to leave what you factored by in front, right? So this is going to be now 5x plus 6. So a lot of people were just writing this as their answer, but you have to state your GCF in front. What did you take out to make it look like this, right? And my inside was because 3 divided by 3, just 1. 15 divided by 3, 5, and 18 divided by 3 is 6. All right? Now that's way easier. Now I can do product and sum. Right? What's my product? 6. And my sum? Yeah. Do all the terms have an x? That's what a GCF is. It's what can you take out of all of the terms. It has to be common between all 3, which all 3 don't have an x, so I can't take out an x. All right? So, okay, product 6, sum 5. I got to think, what works? Really, with 6, all I've got is 1 and 6 and 3 and 2. Which one of those pairs is going to give me 5? Positive 5. You think 3 and 2? Do we also think 3 and 2? 3 and 2. Right? If I did 6 and negative 1, that would add together to give me 5, but then my product would be negative 6, which doesn't work. So you have to make sure it satisfies both. So now, final answer is just 3, x plus 3, x plus 2. And again, it doesn't matter what order of the brackets I put first. It could have been 3, x plus 2, x plus 3. Doesn't matter which one you put first. That's all. But just remember to keep your GCF in front. Keep it. Show the people what you took out to get to that. Right? Let's try another one. What about B? What are they all divisible by? Share. Where did my pencil go? Oh, here it is. Okay. So Sarah, what did you say? That there's no... You change your mind? You revoke your statement? Okay. Same thing with B. What can I take out of all of these terms? What are they all divisible by? 4. Remember, this guy's kind of hinting. 4. If I take out 4, what am I left with in the brackets? This term's going to turn into m squared because I'm dividing. Negative 32 divided by 4 is minus, you say 8. M. And then 48 divided by 4? 12. Quick maths. Right? So then, same thing. Now I can just do my product for this stuff, right? This is going to be, my product is, Sarah, you said 12, and then my sum is 8. So now I have to think about all the different combinations that can make 12. So like 1 and 12. Ooh, 1 and 12. What else? 2 and 6. 3. Oh, 3 and 4 can make 12. What did I hear over here? What did you say? Oh, it's negative 8. Yes. Thank you, because we keep the sign. Here, I'm going to scooch this over. Boop. Yeah? I think that's all. If it's 3y times y, then it's just 3y squared. Because it's like you're saying 3 times 1 is 3, and then y times y is y squared. We don't add the coefficients. Right? So, okay, here are my combinations of things that could make 12 or multiply to 12. And I have to make negative 8. So Zimbu says -2, -6, which I can test it, right? If you get out your calculators and you test it, you could do -2 times -6, positive 12, and then -2 plus -6 is -8. So that one works. The other ones do not work. All right, so I'm going to scooch this up, or I'll leave it there. So then final answer, I want to go back to pink. There we go. Is going to be what we factored out in the beginning, the 4. And now I just do my 2 brackets. What are my 2 brackets going to look like? X minus 2 and X minus 6. Voila. Does anyone want to try the third one? Yeah? Ashley, you want it? Okay, Ashley's going to try the third one. So I think, what are all of these terms divisible by? Have faith. It's okay. If it's wrong, we erase it. That's all. Voila. Okay, Ashley.
Do I have to explain it?
Yeah, tell the people what you're doing.
Okay. Oh, you're recording. Okay. So I found like the GCF, and it was like 5 because everything's divided by 5. So I like divided it and made like brackets. Product. What the heck? So, and then like the do 2 and 8. Okay. Did I do it right, Grace? Oh.
Thank you, Ashley. So perfect. So Ashling said, peeps. So Ashling said they're all divisible by 5. I'm going to take out 5, and I'm left with k squared plus 10k plus 16. And then we did product and sum. Product 16, sum 10, and she found 2 and 8 work for both conditions. So final answer is just 5 times x plus 2, x plus 8. Thank you, Ashling. Right? So some of you are asking me, because you're already rushing to this, what if you have 2 variables in a set of bracket? You have x and y, or a and b. You're still going to do expanding like normal and product and sum like normal. So for example, if we do option 1, which I'll call this one 1 and this one 2, if I expand this, doing my normal foiling, right? So first, outer, inner, and last, what do I get? What does this leave me with? Plus 4x. So, okay, I'm even going to go the extra step of showing x times 3 is 3x, 1 times x is just x, and then 1 times 3 is 3, which Calvin then said simplified all the way is x squared plus 4x plus 3. Done. If I do the same thing with number 2, right, and I'm saying x plus y times x plus 3y, remember, like terms, if they are not like, they do not go together, and we are multiplying. So if I FOIL again, x times x, x squared, x times 3y. We're expanding. It just says expand. You just got to read the question. This was also a common fact. Yeah, Alex? Yeah. This was also a common thing on tests. A lot of people do not read the questions sometimes, and they just jump into stuff. Like, instead of factoring, they just wrote GCF this. And I'm like, okay, but you still have to factor it, right? So take your time, read the question. Or when it said, for the communication question, when it said which two questions in question 1 were special products, some people only circled 1. And it's like, but there's 2. It's telling you there's 2 options, right? So even you could have taken a shot in the dark and like guessed, right? But you got to read the question. So this one's just saying expand and compare. So okay, we said x times x is x squared. X times 3y. What is that going to look like? 3xy. That's it. I'm not making it anything with squares. X and y are 2 different terms, so if I multiply them, they just squish together. Right? Same thing. Y times x is just xy. And then y times 3y, this is going to be 3y squared. Because this is like saying like 1y times 3y. 1 times 3 is just 3, and y times y, y squared. Right, so that's where it comes from. Is there anything I can like simplify or collect like terms for? Yeah, Ashley? Yeah, these 2 middle terms I can put together, 3xy and xy, so that's just going to be 3 plus 1, right? I'm just adding the coefficients together. So this is 4xy and 3y squared. xy is 1 term. The coefficient in front is 1. Right? So I'm not saying like, oh, there's 2 x's, so that's 2x, and 2y, so that's 2y. We're not doing that combination. It's just the coefficient in front, right? What do you notice about these 2 answers? How are they similar? How are they different? What do you notice? What do you notice? So you're saying like the same numbers, like 1, 4, and 3? They're the same, right? This is still x squared. This is 4x, but this one has a y attached. And same thing, this one has a y squared. So that's the only difference, is that like your y's, whenever you have like a second variable, you notice it gets attached to the middle term and the last term. That's all. Right? So if we were to practice this, right? My first one is just going to be what? If I do x plus 4, x minus 6. If I FOIL, what am I going to be left with? Ooh, minus 6x plus 4x minus 24, which then simplifies to, what can I, minus 2x. So then if I do this one, where I've just got a y attached to my second term, it's going to look very similar to this, but you're going to notice the middle term and the last term will have y's attached to it. Right, so now what's this going to be? X times x is still just x squared, but x times negative 6y? Exactly. Yx is technically not wrong, but we like doing alphabetical order, right? X comes before y, so do xy. And then same thing, 4y times x, and then just 4y times negative 6y, minus 24y squared. Right? And then combining these 2 middle terms, I can put them together. They're alike. Bless you. This is going to give me minus 2xy minus 24y squared. So even if we just compare, same numbers in front, same coefficients, that word again, that vocabulary, same coefficients, just y's attached to the middle and last term. So that's the only difference. Yep. I don't know if I would ask that kind of question. Yeah, this would just be it. I would just want to see algebraically. I wouldn't need you to like explain it in words. But I don't think I'd ask this. So okay, before I send you on your way and practice, let's try it. Now I need to factor. So again, my product is still, don't be alarmed by 2 variables. It's still my last term. product is still whatever C is, which this is technically C. It comes last in the expression. So my product is going to be what? What's this number? 24. And my sum is still my middle number. That has not changed. 14.
Is the product number always going to be bigger?
Most likely, yeah. If we're multiplying, yeah. For now, what we've learned, it's always the last number, and sum is always the middle number. We're going to learn about, like, what if you can't factor out a GCF? Then there's a little extra stuff on top of that. But okay, what combinations make 24? 1 and 24, what else? 2 and 12, what else? 3 and 8, 4 and 6. Okay, now I need to test which one's going to give me 14. Which one looks promising from this group? Yeah, my 12 and 2, right? Because 12 plus 2, that's 14. And 2 times 12, that'll make 24. So now this is just going to be, remember, our two integers. If I set up my brackets, first integer, we're going to just have m. And then instead of saying plus 2, it's just going to be plus 2n. So you're just attaching your second variable now onto this. So before, we would just do like m plus 2, m plus 12. Now this is going to be m plus 2n and m plus 12n. So that's the only little extra thing. Just add your n's onto this new integer number. Cool. Okay, what about the p one that I got below here? All right, my product is going to be 15. Thank you, Georgia. And my sum, what's my sum going to be? Minus 8. Evan, you think? Negative 8. Okay, now all the things that can make 15. 1 and 15 to start. What else? Not 2. 3. 3 and 5. And I think that's it. That's the end. Short list. Which one of these is going to make 8? Thank you, Harlow. Negative 3 and negative 5. Because that multiplied together, two negatives make a positive. And negative 3 plus negative 5 makes negative 8. So then what are my brackets going to look like? First letter by itself, P, and then what? My second letter is Q. So this is going to be minus 3 what? 3Q. And then second bracket, P minus, 5Q. Right? So instead of P minus 3, P minus 5, like we're used to, you're just adding the second variable. Would you like to do C? There you go. George is going to end us off on C with W's. W and Z. Okay.
Okay.
So, talk us through it.
Product is minus 10. Well, 10, I guess, doesn't really matter, but.
Yeah, negative 10. And sum is negative 3.
And it adds to negative 3. And negative. Wait, did I do that? Right? I'm reading the wrong one, sorry.
That's okay.
That is a negative 5 and a 2.
Okay, so negative 5 and 2. Multiplied makes negative 10. Added together makes negative 3. Perfect. Thank you. And you might think, why is it not like Z minus 5W? Again, alphabetical order. Follow alphabetical order. W comes before Z, so that's why W is by itself. Right? Also, Z's the one with the big numbers attached to it, not W. W kind of stands alone here. So that's why it's W first by itself, and then your second variable. How do we feel about this? Upside, down? How do we feel? I see some thumbs up. This is just one little step up from what we did yesterday. So it's just going to take practice. Okay, and that is it. So I've already uploaded, and I'll switch back if someone's still copying, the homework. It's already on the Google Classroom, or I have like a spare textbook somewhere it was floating around from yesterday. So those questions, practice. If you didn't get a chance to practice these ones yesterday, I would say try those ones for just regular product and sum. We're never going to do algebra tiles. Ignore these things. We're not going to do them. I'm never going to test you on them. They're like a high and buy thing of grade 10 curriculum. You see them and then you never do them again. So I'm like, not going to waste your time. We're not doing that. So practice those, and then we're going to start learning, what if you can't factor out a GCF? So that'll be tomorrow. Okay? I'll go back to this in case we're still copying.